Yeah, so let's look at another example. A double-digit increase is not an unreasonable goal, especially in countries and regions that are not exposed to extreme weather events. Okay, so when we do keyword search, unreasonable is a negative word. Exposed is also a negative word. That's in the LM dictionary. So these two are negative, but you see, this is a double negation. So you can see that not a reasonable goal. If you just count unreasonable as a count negative, and you have a problem, which is it's actually they say not unreasonable. It's actually reasonable, right? So this is something is wrong. It's another problem. Another problem. Another thing is so the countries and regions are not exposed to extreme weather event. So in that case, so basically, what matters is the exposed is modified country and regions, and then this is we don't care about country and regions. We care about earnings. We care about sales. We care about all this stuff. So basically, there's a two problem here we want to represent. One is double negation, which means this is one problem. Another one is there's we call this co-reference. Co-reference means this exposed modified some pronoun. The pronoun represents something. If the that represents earnings, sales, graph, that's what we want. But the that actually represents the countries and the regions, which is we don't care. So this is another case, like, I don't know, Michael, that help in this case. This one is a simple example, the bad weather they're together. So, but here in this case, the exposed actually related to that related to the country and the regions. And we don't care about country and regions. So we don't care about exposed here too. So, so this is another example. We have to know the context of this. So we have to know what the exposed modifies. If it modifies country and regions, that's something we don't care. So, so these are the examples. So we see two problems. One is double negation. We see that the subject of the term of the words, like what kind of subject of this action, like for this one, the exposed is to country and the regions. So we see that two problems. We want to resolve that problem. So there's one way we can do is if you know the syntax of any two words, you will have the problem resolved. So let's say here, if you know bad modifies weather, and if you know the great modifies sales, if you know that this is relationship, modified relationship, and then you can identify whether the subject is performance related or non-performance related. If it's non-performance related, you can just ignore the bad. If the great modifies sales, if sales is performance related, you can just count them. So basically what we want is the relation between any two words. So going back to this example, the not actually modified unreasonable. We want to know that because the not, we don't know not, maybe not is for negate what? Not is negate unreasonable. If we know that relation between these two, and then we can flip unreasonable. So whenever we find the unreasonable get negated by some not, we just flip the negative into positive. Same here. If we can have the relationship between the exposed to that, we know exposed will modify that. And then if we know that modifies country and regions, and the country regions is not our performance related, we can just ignore the exposed. So so the key here is for any sentence, we want to know the relation between any keywords. Like for example, the not negates unreasonable, exposed, it's modified by not, exposed also related to that is also referred to the country and regions. We want to know all this information from the sentence. We want to know all of them in order to process this, make things right. And how we do that? But are we? Am I just pause a little bit? Am I clear about the examples and the information we are missing? Okay. Yeah. So we are missing the information of the relation between any words, like who modifies whom. We miss that. We have that. We can make things right. Make sense? Okay. So how we get this? How we get the information of this? So this is this is supervised. People are trained it, so you can just use it. So let me explain you what we have, and then you can see how you can use them. So of course you can use that right now, right? You can use that once we have the information, we can make things right. So how we do that? So the procedure is there are 3 million words from the Wall Street Journal, IBM, Computer Science Manual, blah 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 blah. So they want to make the sample comprehensive. So linguistics did that. So what they do is they label these words every sentence. So for example, not modifies unreasonable. They define the relationship is like something, and the core reference means that refers to the country and the regions. So this one refers to the country regions. This is called the core reference. So there are 98 type of relation in every sentence to define the syntax of the words. So including no relation. For example, events and the double, or events and unreasonable. These two has no relation. So basically, the linguistic literature define every sentence, every 2 words. There are about 98 type of relation, like subject, object, like a negation, blah blah blah. So what do is human first label them for every sentence. Human label. The human just point out, oh, this one modifies this negation, this is core reference. Human label everything. Label 3 million words of this. So this is training sample. Okay, that makes sense. So human label this. The human will give you what's the relation between any words, including no relation. So human give this. This is called a pen tree, or you can call it arc. The arc means this arc means define anyone. This pen tree is it's a linguistic did that. Okay, and later on, computer scientists they want to use this as a training sample to meet, because this one is labeled is constrained to this IBM manual, blah blah. We want to use that to annual report. We want to use that to conference call. We want to use some other sample, right? So what they do is train a model. This model is called it's a neural network model, but it's already trained by the NLP group of Stanford, and many people are using this too. So what they do is they use this model to replicate the human intelligence of recognizing this sample. So what they do is we have a 3 million text. So we divide the 3 million text into 10-fold, right? And what you do is you're using the 90% of the sample to train a model, and you use the predicted the relation to and then use that model to use the holdout sample. So we have a 10% holdout sample. So you use the 10% holdout sample to check the performance of this model relative to human recognition. And then what you do is you will do another 10. You will divide the sample $3 million to another 10-fold, and you get another new holdout sample, and you train the model again, and use the trained model to check the model in a new holdout sample. You repeated this many times. The reason is because you want to make sure your model can represent the human intelligence of recognizing this relationship. So right now the model accuracy is 92%, which means you randomly draw any holdout sample from the corpus. The model can predict the model's accuracy, and the human accuracy is 100%. The model accuracy can get the 92% of accuracy of human labeling this relation, the any relation. So so once we have the model ready, once we make sure the model can apply to out of sample, you can use the model to conference call, to annual report, to CSR report, to anything. And the model has been trained many years because of it is very complicated. There's so many labels. 99 is 99 outcome, 99 types of outcome here, and then so the neural network, innovation they did is this is so the neural network is like each neural can do the dimension reduction, right? In the video you guys can see like for each this is like a filter. You give the information to the first filter, they take out the bad information, they retain the good information, and the filter again, until they get the best information and along with your prediction. So check my video about the neural network. I don't spend too much time talking about it right now, but one innovation they do is they tune the activation function. So each one is called a neural. The neural is help you to filter out bad information, to retain good information. So activation function in the neural help you to get the good information, and they use a cube activation function. So if you check their website, this group tried so many models, and they find the cube activation function is the best to get the information for the syntax, for the arc information. So they don't know this ex ante, they just tried, and then just try and tune it until they found that's the best activation function to get the information. And so why we want to do this? We want to do this is once you have the model, you can apply the model to any other data, and you don't have to human to get the relation between any words. So you have the model apply to any text information, you can get the syntax, and then use the cross validation. You know that it's 92% of accuracy with human labeling, and so you can see that this is a training process. So at the beginning of the time, it's like the machine only can mimic human very low accuracy, it's just low intelligence. But along the time, the more you train, you can see that the more you train that the machine can actually more captures humans' pattern. So this is the process of training. The more you train, the machines become smarter. So that's the difference between the OLS and machine learning. OLS, one-time optimization, done. The machine learning is optimize again and again and again, and get feedback from the failure again, and just do it. So this is this is another example of using deep learning to resolve the problem. So let's go back to see the So let's go back to the problem we see earlier. So now, before you don't have the information, bad modified value, great modified cell, you don't have that. But you put this one into the Standford parser. Standford parser will tell you this one modifies this. So in that case, you can just say, okay, let's ignore bad. Let's just count great. So things will become right for this example. Make sense? Okay. So here you can see that after you put this sentence using Standford's parser, you can know that not, negate, unreasonable. So you know not negate, unreasonable, and then you just flip it unreasonable, right? Then these things become right. And then exposed is the negation. Okay, you make it right. And then this one modifies that. Stanford will tell you this one modifies that. And that refers to country regions. And country regions has nothing to do with performance. And then you ignore this whole thing. So this one also make it right. So once you know the syntax between any two words, you can make adjustment to make things right. So the difference between this one and Google Bird is Google Bird is difficult to interpret, right? You don't know what's going on. But here, the interesting thing is you know the relation between any two words. They give you the tangible output of any pairs. But the problem is the sentence has more information than that. This one, you only get the syntax between two words. There are much more information than just syntax of two words. But this model only capture that. We ignore some other information. But Google Bird capture more features than this model. But Google Bird is difficult to interpret. This one, straightforward, tangible. You can see what input, output. But they only capture the syntax between any pairs. But they're missing other information. So which model you use depends on the question. I mean, if your question is want this, later on, Jingwen will present a paper. That paper, I feel this model is better, so I use this model. Hugo will present the model paper. I feel for that question, this model is better. I have another paper, I use Google Bird, because Google Bird can fit the question better. So I just depends on the question, and which model you choose. And both are pre-trained. You don't have to train anything. So like I said, this is the input of the model. Output is this. This input output. Once you have output, you can just do the justification. You can just do, once you have the output here, you can make things right. So that's at the sentence level. Google BERT and this one, you can use that. At a single word level, you can use keyword search. You can use dictionary. You can use word embedding, and so that's what we have without training the model. For training the model, we'll talk about later on, but that's different whole paradigm. So without training the model, this is what we have for textual analysis. And yes, Lou, right, Lou? So we explained the list of technology. So how we can use them. So I want to take just a couple minutes to just finish up like what kind of applications we can use, and we can go to the papers so you can see the concrete example of using this. So at least several things. So we have bag of words, unsupervised, supervised, self-supervised, transfer learning, ensemble learning, knowledge graph, reinforcement learning. So bag of words, if you guys use it, just use it. I mean, people will push you to the later part, but just easy stuff. Yeah. So unsupervised, just not reliable. Just avoid it as soon as you can. And supervised, time consuming. You have to label them. So self-supervised and transfer learning. These are the two I recommend. So these are the pre-trained model. You can use them, and just input output. Ensemble learning, just you ensemble stuff together. Knowledge graph, put it away. It's a little bit too much for you guys. Reinforced learning, I think a little bit too much. And so there, I think the self-supervised transfer learning and bag of words, you guys can dig into it. I told you I'll give you guys some video. You can dig into that. And how to do the performance evaluation. So you have accuracy, precision, recall. Normally we look at F1 score. So use F1 score, you can get what model is the best. So that's you do the model selection. So I also quickly pass. Okay, another thing is how to interpret the model. This is like a lot of my paper people challenge like black box. Like we are black box. Like we are just fuzzy word. Like so interpret the model is very important. So there's different ways to interpret the model. So I guess I want to skip here now. Otherwise it gets too complicated. You can check the video I sent you guys to, and I did. So what kind of application we can do? Okay, this is what we emphasize. So we have three ways to use this machine learning. One is we call it information retrieval. So basically use the machine learning to extract information from the 10K conference call, which we cannot extract earlier. So basically, like say you want to get the climate risk. So you use the machine learning can extract the climate risk from annual report. And then once you get the climate risk, you do whatever regression, blah, blah, blah. That's the first way you can do it. The second way is use the trainer model like the paper, the alpha analyst, the machine analyst. You tune the model to predict stock price, train it again. So that's what we can do. The third one is you don't do any machine learning. You just look at the policy. So if a company adopted the machine learning, what's the implication or consequence on the company? So let's say the bank, I forgot the U.S. bank, I found that 2015 or the regulators encourage the bank to use big data to identify credit risk. Okay, that when the shock comes out, what's the consequence on the bank's credit risk? So that's kind of typical diff in diff design. You don't even need a machine learning. It's just event-based study. So these are the implications you can use the pre-trained model to gather information, do OLS, or train your own model, or just traditional diff in diff, but this is also technology related. And so challenges. I just want to share challenges with you guys. Normally people will focus on the story, not technology. So like a lazy price. So Lauren Cohan has done when there's a new information in an annual report compared 2 years, they will use frequency based. You use advantage. I use the fancy Google BERT. And it's very difficult to fly because the story is the same. You just do better job. And so people will not do that. You want to answer a new question. That's the story is important, and also explain the technology. Sometimes, so if you look at a lot of Google BERT paper, sometimes you don't get what is Google BERT. So sometimes you want to use a very simple example to explain them. Make the people who do not have computer science background understand the technology, how to use them, and the audience, the referee will approve it. If referee don't understand, they will not sign off. They will push you all the way to the end, and eventually bad outcome. So you have to make them understand it, and also justify it. So I give you guys so many options, right? Google BERT, Stanford, word embedding, keyword search. Which technology you use, you have to justify that. People will always question you why. So there's a conference I said earlier. I was organized the review of financial studies. We have so many conference there, papers there, summarize. There's a lot of technology there. So later on, if Michael, we want to host some conference, rather than we can also get some similar textual analysis conference. We can also solicit some papers. So I can give you some some package you guys can have. So the skinning, that's a Python package for machine learning, and also some vectors. So this package. So if you want to do neural network, do keras first, and then you do TensorFlow. So this so if you get to that level, we can talk about this specific package, like what package you use according to the algorithm I just mentioned earlier. So